Hello! Boy, what a way to start out the semester. Um, uh, Hello, everybody. Welcome to EGR 420. You all know who I am, so I don't know if I have to introduce myself. But for those of you who don't know, because it's been like a month since I've seen some of you, my name is Dr. Kale Stoley, and I teach engineering. So I have posted the syllabus already online. I wanted to make sure that you had this information available to you. Full disclosure, when I'm feeling 100% and I'm ready to come back and be a part of society, hopefully by the end of this week, I will then have to leave you again because I have jury duty next week. So, good news. I can't think of any good news. I won't get to see you for like 2 weeks. It sucks. The Doan faculty have adopted a policy where we are all supposed to cancel class next Monday for Martin Luther King Jr. Day. I was honestly a little surprised that we did not have class canceled for Martin Luther King Jr. Day already. So, I guess now we just really don't have to do Martin Luther. Well, now we just won't have class on next Monday. I'm going to be recording some videos for next Wednesday and potentially next Friday because I am not sure whether or not I'm going to be here on next Friday. I can pretty much guarantee I'm not going to be here next Wednesday. Jury duty always takes at least 2 days. And they are really strict about not letting me out of my duties. Making sure things are as hard for me as possible. Anyways, so that's where I'm at. We'll go ahead and talk about this class. You've seen all of my syllabi before. We do have an open source textbook. This is through McGraw-Hill. I think the link to the textbook is at the top of the syllabus. I also put this on the class. We're going to be using this textbook just for reading assignments for this course. Now, the course progression isn't going to exactly follow the textbook. I guess I'll talk a little bit about that as we go through the syllabus. First thing that I want you to notice is that there are only 2 types of assignments in this class. This is an upper level course. And in an upper level course, grading homework is not a good use of my time, if I'm honest. And homework assignments are really not as useful for this type of a class. I see this as more of kind of a design class. So rather than doing homework assignments, you're going to be doing projects. And they're going to be pretty much nearly weekly. Outside of projects, you're going to be doing weekly reading assignments. That's just to supplement you a little bit of information on robots and robotics, and all of that fun stuff. As far as course scheduling goes, we're going to be discussing the 3 major pieces of advanced control systems for the entire course. We're going to start with actuators. I have my reasons for there. We're going to briefly cover controllers, microcontrollers, microprocessors, and then we're going to jump into sensors. And then we're going to be working on a project for basically the last month of class. Now you'll notice here there's a total of 8 projects here. These are mini projects, except for project 8, which is a major project. And in each one of these, it's getting you some experience with working with actuators, working with sensors, working with controllers, microcontrollers, that type of thing. Again, this is more of a design-based course, so I want you to be thinking not just how do I apply course material, but what can I do? What kind of skills can I learn? What kind of things can I use this class for? So that's the syllabus. I've gotten through the fun part of this first class. Thank you for your comment, Walker. And now we'll jump into our first lecture. First day class is usually never all that intense. So what is Advanced Systems and Controls? Well, this class is intended to expand on EGR 350. In EGR 350, we talked about control systems, we talked about systems of equations, we talked about integrating different types of systems, electronic systems, fluid systems, mechanical systems, integrating them all together, using physical properties to be able to put these systems together and actually do something with them. Now, what we've decided to do with this course is there was no way we could cover everything in systems and controls in one class. And quite frankly, there's no way that we can cover everything in systems and controls in 2 classes. And so what I've done with this course is I've made it more mechatronics, robotics related. I'll go into a little bit of why we're going to be covering those topics towards the end of this lecture. But the whole goal of this class is we're going to take what we learned in 350 and do something a little bit more in-depth with it. Now, if you took 350 with me last year during COVID, we did a different type of project, we did a different kind of instruction entirely. If you took it with me this past semester, again, it was very different. I've switched up how I teach that course. I've switched up the kinds of projects we do in the course, so we have a fun mix of students in this class who have taken 350 with me who have had very different experiences. Hopefully we can pull this together and everybody can get something out of this. Now, some of the specific topics that we're going to be getting into in this class include mechatronics. Now, mechatronics it's a fun, fancy word. There's several words that mean the same thing, but the idea here is that mechatronics is specifically related to mechanical electrical systems. Oftentimes what you have is an electrical actuator. This may be an electrically actuated piston or an electrically actuated linear actuator. And then you similarly have mechanical linkages that transfer the power that comes out of that electrically actuated device to other mechanisms. So this is kind of your very traditional robot. If you want to think of a very simple mechatronic system, any robot is a mechatronic system because it has electrical power that powers all of the joints, and then they're transferred through mechanical linkages. We're also going to be talking about electronic control. In 350, if you took 350 with me this past semester, we didn't get as much into electronic control as we did last year. I had my reasons for that. I wanted to actually focus on a little bit more broad topics on 350. But the overall goal with 350, well, with 420 here is we are going to be talking about electronic control. How can you use a microprocessor? How can you use a Raspberry Pi? How can you use a computer to more finely control processes that are happening? We're also going to be talking about actuation. Now, actuation is, I've used the term actuator a few times. An actuator is basically something that takes a physical principle, power of some kind, and converts that power from one form to another. So now an electrical actuator would take electrical power and convert that into rotational energy or translational energy. You have the more chemical actuator, this is like an engine, something like that, where it would convert chemical power into mechanical power. But the actuators, they're a critical piece of all of robotics. So we'll be talking about that a lot. We're also going to be discussing advanced sensory systems. I've hinted at these a lot in previous years, but we haven't really gotten into a vision system. We're going to be doing vision systems in this class because vision systems are they're incredibly cool, if you ask me. And understanding how vision systems work and understanding how to make them work and how to work with them, it's something that's really beneficial for anybody who wants to understand advanced control systems and robotics in general. Vision systems have become a staple in modern robotics because you have to. You have to be able to see the environment around you. Why are we using camera systems? Why are we using technology that was literally invented like 60, 80 years ago? We've got, well, cameras were invented way longer than that. But this is the modern state of technology, being able to use cameras and integrate them into systems. Why is that advanced? Why is that considered an advanced sensory system when it's something that we've had forever? We'll talk about that. Okay. Now I will say that this course pairs with courses that many of you have already had. Now, I will say that not all of you have had every one of these classes. Some of you may not even be a mechanical engineer and may not have taken machine design at all. Whereas on the flip side, some of you may not be an electrical engineer and may not have any idea what digital circuits and microcontrollers is. So there is kind of an interesting pairing of topics here because, as I've said, it involves a lot of electrical actuation, but the controllers themselves, they abide by the principles that we learned in digital circuits and microcontrollers. The controllers that you built, the circuits, the wiring, the how to hook up microchips, how to take memory pieces and put them in there to build a nice control system for it. That's all 335. Machine design is how do you take these linkages, now that you have the actuation, how do you take these linkages and transfer the mechanical power? So this class really is, it's very interdisciplinary because it does require a little bit of knowledge from several different areas. And if you've already had digital circuits and microcontrollers, if you've already had machine design, if you've already had both of them, there's I think a couple of students who are in this class who've had both of those courses. This is a good opportunity for you to try to understand both sides of this. How do you build the controller, one, but then how do you build the mechanical pieces that actually move appropriately and transfer all the power? So lots of unique ability to do some interdisciplinary learning here. Now, what are we going to be doing in this course? We're going to be expanding on our previous course materials, like I've said. And this is, the goal here is I want to make this more of a design experience. We're going to be doing mini projects. A lot of the mini projects are, can you integrate X into a system? Can you integrate X into a system? And just give you a little bit of experience with working with different components that you might see in an advanced control system. How do they operate? How do you make them work? We're going to be doing a lot of construction of physical systems. I know this is kind of ironic for me to tell you this virtually, but this is supposed to be a very hands-on, in-class, working together kind of experience. I want all of you to build stuff. That's the best way to approach this class. We're also going to be talking about identifying and analyzing different foundational robotics concepts. This is part of the reason why you're going to be reading your textbook. I'm also going to be sharing some videos with you. There's a lot of really cool stuff going on in robotics, and there's a lot of stuff that I think people don't quite understand about robotics. We're going to be talking about those in this class as well. And finally, the whole goal for this class is to build towards a comprehensive final project. I want you to build a robot. Okay? And I want to make it an intelligent robot. What is the difference between a non-intelligent robot and an intelligent robot? Well, an intelligent robot has a built-in control system into it where it has the ability to quote-unquote make decisions. If you remember the fact that we talked about feedback loops in 350, a feedback loop allows a control system to make excuse me, to make an informed decision. And I'm going to die on camera. Excuse me. It allows the system to make an informed decision about how its behavior needs to be. So What makes it intelligent is that it has the ability to respond to its environment, it can react to stimuli, and then it can overall take that stimuli and make decisions based off of that. And yeah, we're not going to be getting into something that's like super mega AI driven, but we are going to be doing some pretty cool stuff as far as developing an intelligent robotic system. So that'll be towards the end of the semester, and all the projects we have moving up to that point will all build to that. So, doop doop. Okay, so why are we talking about robotics in a class that's called Advanced Systems and Controls? Um, well, if you talk about robots, now I'm going to take a little bit of a segue here. If you talk about robots, robots are integrally three pieces: a sensor, a processor, and an actuator. A robot will take information from the sensor, we'll put it into the processor, which already has pre-coded into it defined activity. Now, some of that may also be, I want you to move here, I want you to do this, I want you to be here, which can take user input too. So you have processor also getting user input, but also taking its pre-programmed nature, taking this data that comes from the sensors, and outputting movement through an actuator, or multiple actuators, I should say. So that's the basic basic structure of a robot as we understand it today. Now, the modern definition of a robot is really just an advanced control system. As we talk about control systems here, there's not a whole lot of difference between what a robot is and what an advanced control system is. Robots are the pinnacle of advanced control systems in my mind. But the definition has kind of become skewed to where we have people will refer to robotic buildings, which is it's a little funny to think about, but it is true to the definition. It has a sensor, a processor, and an actuator. And here you have buildings where they can seal off light at certain times of day. You have buildings that can respond proactively to vibrations. You have buildings that have control for their lighting on the inside. You have buildings that have control for all of their HVAC systems. So really, you have a lot of intelligent systems that are already present that do have this very sensor, processor, actuator style of integration, and those are called robots. Now, if you ask me, it's kind of a gross use of the word robots, but it's true. So here, when we're talking about robots, there's a lot of things that you can consider a robot to be. It's not just that humanoid doot, 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 robot thing. There are robots that are inside of our HVAC systems, and that's just kind of what we have to get used to here. Now, I want to specifically study robotics because, first of all, it gives you a better insight into advanced control systems as a whole. The more you understand about robotics, the more you really come to understand about why control systems act the way they are and why they're necessary. Robots also allow us to integrate artificial intelligence. Artificial intelligence is another really fun, really poorly used word. That in today's society, it can mean anything from having a feedback loop that allows a system to make decisions. Having a simple feedback loop, which you can do in like 120 lines of code, having a very simple feedback loop like that can be considered AI. As I've said, that's kind of a gross definition of AI, but get used to today's language. People love the word AI, so people have started using AI where places where it really doesn't mean anything fancy. Now, we're going to be working with algorithms because that's really what a controller is it's a type of algorithm. And so we are going to, because we are putting this into an intelligent system, we are developing our own AI. That's, again, a gross use of the word, but that's today's technology. has allowed us to destroy language like that. Finally, robots are just awesome. I mean, let's be honest here. If we could all build robots, it'd be great. Um, so, why are robots important? Well, robots, uh, there are a whole bunch of reasons why robots have become more and more prevalent in society. Why people are doing more research on them. First of all, robots do repetitive tasks well. Any advanced control system with proper actuation, it's put in the form of a robot, has the ability to handle processes that have to occur repetitively over and over again. Okay, like I'm sure you've all used Scantron tests. Okay, Scantron tests are very repetitive because you just go through and check, did this person get this one right? Did this person get this one right? Um, it's very repetitive, and people don't handle that very well. People are not made for repetition. People like variety. So any repetitive process that has to happen multiple times, robots are increasingly being used in every one of those applications. Um, Robots can do labor-intensive tasks well. If you have to pick up 50 pounds for a person, I mean that's, go look at the Lasaus guy. Those guys can pick up 50 pounds and they could probably carry it, 100 yards and they'd be fine. Um, but if you have to do that all day long, 8 hours a day, and you have to pick it up and put it back down, it is going to cause you back problems. So what we found is that robots can do this and do it much better because it doesn't cause robots back problems. There aren't health complications to lifting. You don't have the, if something falls over, it might destroy a robot. Well, if it destroys a robot, you've destroyed a piece of technology that costs money. If you destroy a human, if something falls on a human, crushes them, people usually don't like that. It's not a good day. So, robots have been used in places where there are hazards to humans, and they're not always the hazards that we typically think of. We want to say, oh well, just don't be a wuss, just get out there and do the work. Like, no, quite frankly, there are still some risks to picking things up all day. There are some risks to bending over and straightening your back up all day long. You want to reach down and grab something from the bottom shelf? Yeah, it's fine once. You want to do it 50 times a day, you start to feel it. Okay? You want to crouch down on your knees 50 times a day, you start to feel it. It's something where, these labor-intensive tasks, they're better done by robots because it don't hurt the robots. And we can specifically design the robots to handle that specific loading condition. So we're doing this as a way of protecting people, and we're doing this as a way to take on some of the jobs so that people can do things that don't require a lot of heavy work. Work smarter, not harder. It's kind of a principle of robotics. And lastly, robots do very precise tasks very well. And this is probably one that's kind of intuitive to you. If you need to do a weld, and you need to do a very specific weld over and over again, robots can just do it better. I know that there are professional welders who are fantastic. Yes, that's great. You can be as flexible as you want, but at the end of the day, a robotic system can do a weld much better and much more consistently over thousands of welds than any human can ever do. Similarly, if it comes to placing parts on an electrical circuit, robots do it better. You have millimeter level precision, you have sub-millimeter level precision on some of these circuit boards. Humans trying to place those components, that's not easy. For those of you who took 360 with me last semester, trying to do SMT soldering, you know what I mean. Just doing that with a robot is 1,000 times better than trying to do that with your hands. So these very precise tasks, anything that requires a very fine-tuned task, a robot is better at. So you can take a look at this list of things, and really this is a very quick guide to how you can innovate and change the world. Okay? If you can figure out a way to make repetitive tasks easier, You can figure out a way to take labor-intensive tasks and reduce the labor to humans, and you can take very precise tasks and make them more generalized so that humans don't have to do the very, very fine-tuned work. If you do any one of those three things, you've developed a robot that can be useful in society today. And just as a hint, modern robots, I've been looking into robots. Current lowest price I could see for a robot was around $20,000. And this is for an industrial system. So, if you can solve any of these problems for less than $20,000, you've created yourself a market. Just saying. All right, so again, why are robotics important? Well, where are robots used? Robots are used extensively in manufacturing. Okay, you go down to any manufacturing facility, robots are used. If you've ever heard of a CNC machine, CNC machines are robots. It uses robotic control of milling and drilling bits to create very fine contours. 3D printers are robots, believe it or not. You have intelligent structures. As I mentioned earlier, buildings are becoming more intelligent. They have the ability to shed light. They have the ability to open blinds. They have the ability to adjust lighting in rooms. They have the ability to adjust temperatures in rooms. All of these are robotic systems. Okay. You also have robots that are taking measurements. Measurements are another one of those very precise details where if you take a measurement incorrectly or if you take a measurement differently between two different runs, it can lead to a great amount of error. So using robots to take measurements, it actually does create an opportunity for robots to make an improvement. Drones and autonomous vehicles are another really big area of research right now. Autonomous vehicles are, you have companies from Google, Uber, they've even been looking at autonomous flying vehicles. Amazon is right now looking at using drones to deliver packages, which has been a concept that's been out for over a decade now, but people keep thinking about shooting the drones down and stealing packages, which is a federal crime, but whatever. Well, not federal crime, but it is a crime. But still, you're dealing with, this is the world we live in. Things are becoming more autonomous. Healthcare systems, robots, because of the fine, precise nature of some surgeries, robots are being increasingly used in surgical settings because it allows for an incision to be made that doesn't require a doctor to stick his giant meaty claws into your body. Instead, you can have an insertion where a robot the size of a pencil can make an incision, insert itself into your skin, into your organ, perform an operation with a built-in camera, seal it back up, and pop out, which is minimally invasive. It's really incredible the state of surgery that we have today, and a lot of robotics in surgical applications are. I even found a whole textbook on just mechatronics and medical devices. Thought about using it for this class, but I figured that was kind of a very application-specific way of approaching this course. Remote operation. There are a lot of processes that have to be performed remotely. There are some very dangerous situations, such as if you're driving a vehicle and you're driving the vehicle from a long ways away, you can stay safe while that vehicle is out on the roadway. Similarly, you can stay safe while that vehicle is experiencing harsh conditions. You can have a vehicle. There's been a lot of research into being able to actually remotely control semi-trucks as semi-trucks drive through. Now they haven't been able to figure out how to take that and refuel them, but that's a different story. But we now have remote operation systems. You have the ability to remotely operate a robot where a person does not have to be present. This can be done in manufacturing facilities, but it can also be done on construction sites, where you'll have one person who's very skilled at operating a very certain type of robot. All you have to do is move the robot to a certain place and make sure that the person has a connection to that robot, and they can do whatever task with that robot needs to be done without the person actually having to physically be there. So it does allow us to to get tasks done without having people present. We've also introduced robots as a way of enhancing human performance. Now, all of you know who Iron Man is. That is one example, yes, of a robot that enhances human performance. But we do have other types of exoskeletons that are present on the market today. We also have something called soft robotics, and this is a topic that we'll get into later this semester. But soft robotics really provides us with the opportunity to enhance our performance by using our own strength, just with a little bit of added extra kick. And we could talk about that if you all want to. But there's a lot of very specific human performance enhancement robots that people are looking at today, and I've always been curious about getting into that direction myself, but the other end of it, I don't have a whole lot of time. And lastly, there are also robots that are present in toxic or hazardous environments. You may have seen the robots that go into bomb zones and defuse bombs. Why are they robots and not humans? Because robots are cheaper. Because robots, quite frankly, you don't have the scarring image of if a robot explodes, you don't have to go explain that to their family. Human lives are worth way more than just money. People tend to be very sensitive to other people's suffering. So robots, you're in places where you're doing spray-on painting. Robots are typically do a lot of painting applications because paint is very toxic to humans. So we were at Xmark at one point. Xmark has robotic painting systems. Okay, and I know of several other companies that also have robotic painting systems that they use because it prevents you from having to have a person right there painting. So toxic or hazardous environments, robots are very common. They're becoming increasingly more common. Now, again, I'm going to go ahead and step back once. These are what robots do well. This is the kind of environments that robots are currently being put into. There are still other ones that didn't make this list. If you could think of an application that does one of these three things in one of these areas, you could create for yourself a brand new cutting edge robotic system. And that's really where we're at in robotics today. I saw a graphic that said that robotics manufacturers traditionally were places like ABB, Fanuc, a lot of these much larger robotics companies. In the last 20 years, with the advancements that have been made, we have seen robotics manufacturers pop up out of nowhere. You have a couple guys in a garage who build a robot, and quite frankly, they can sell that robot for $30,000. They do it. That's all it takes. So you have some really brilliant minds coming together and building these robots, and all they have to do is make these systems cheaper than the common person who's doing it at ABB and the common person who's doing it at Fanuc. So one of the reasons why we're seeing a lot of these small manufacturers pop up is because there's been a lot of improvements made to different components inside of robots. And we have recognized that these are kind of the future. Sensors are becoming cheaper. We have the ability to integrate $2 sensors into a system. These sensors traditionally cost thousands of dollars to build, and now we have them on a microchip, and they cost $2. You can order them from China. Okay, actuators themselves are becoming cheaper. Now, this is probably one of the biggest costs of robots today, is that actuators are still really expensive. You want to get a really powerful motor, it's going to cost you a couple $1,000s. And additionally, a lot of the mechanical linkages that are used to transfer power from those actuators, that's where a lot of the cost comes in as well. So there is a limit to it, but it's making people rethink, how can we fix actuators? How can we make actuation cheaper? How can we reduce the amount of mechanical linkages that are required to make something operational, so that we can make the overall system just totally cheaper? Control systems are becoming more common. one of the benefits that we have in living in today's society is that we have control systems to build on. The very first person who integrated a lighting control system into a phone, yeah, you see that in every phone now because somebody figured that control system out, and then everyone was like, oh yeah, now that it exists, now I know how to recreate that. That's easy to do. Well, control systems are becoming more prevalent in that way. You have control systems for robots that are perpetuating throughout all of robots. It's industry standard right now that robots have the ability to measure when they hit something. Okay? It's a very simple measurement. But that's become industry standard because it's a control system that we've seen many times in different robots. Controllers themselves are becoming cheaper. Some of this is because electronic components are becoming cheaper. Some of it is because we just better understand how to use these components. But we also have designers becoming more intelligent. We live in a community where we all share ideas. We live in a community where we all continuously advance things, and designers are gaining experience in designing better controllers, designing better robots overall. Robotic needs are changing. Back in the 70s and 80s, robots were needed to be powerful, fast, and efficient. They were very deadly. In today's world, we don't need robots that are super powerful, advanced, murderous. We need robots that are intelligent. We need robots that have integrated sensor systems. So our needs have been changing to where now a robot that may operate at a tenth the speed of a robot of 40 years ago is still more desirable. That's probably also about 1,000 times cheaper, but that's also a different story. And lastly, we've really begun valuing quality of life more and more. Even 50 years ago, 60 years ago, things were dirty, things were gross, and people were just okay with it. In today's society, we really value quality of life. We want people to live good lives, and we do what we can to improve those lives, to improve air conditioning systems, to improve lighting, to improve you even have robotic beds at this point. We really have valued comfort more than anything in today's world, and that has created a big shift in control systems. So, okay, that is it for this lecture. I will see you virtually on Wednesday, and hopefully in person on Friday. So, have a good rest of your day, and I will be posting a reading assignment towards the end of this week that's due next week. We're not going to get into our first project until 2 weeks from now because, again, I've got jury duty next week. But you will have a reading assignment due next week, and the textbook it's online. I give